Hello, welcome back, Math Scholars. Professor McMath here with another wonderful video. Kyle, hope everything's going well with your wonderful not paying attention in class, so hopefully you enjoy this one. Sorry for all the other classes, Kyle demanded shoutouts. Anyway, so we are doing adding, subtracting, and rational expressions today. So last time we had talked about multiplying and dividing those rational expressions. This time we're going to talk about adding, subtracting them. So similar to how we added and subtracted normal fractions. So if we had, like, for example, like 1/3 plus 4/3, we'd simply add the numerators because the denominators were the same. But if we didn't have a common denominator, like if we had 1/2 plus 1/5, we had to make them a common denominator, where they would have a 10 in common, so this became 5/10, and then 2/10, so the answer was then 7/10. So we'll have to do similar things there, where if our denominators are not the same, we will have to try and work through a factoring process to figure out what things they do have in common and figure out what we need to have there. Some of these are pretty straightforward. So we have x plus 1 over 6x squared minus 12x plus 6x over x squared, 6x squared minus 12x. Same denominators, so we'll add the numerators. X plus 2x becomes 3x. Plus 1 over our 6x squared minus 12x. For the straightforward examples where they have a common denominator already, you probably should factor the denominator as far as possible. That way you can verify that nothing actually cancels out. And in this case, nothing does cancel, so we were fine with the original answer. Okay? No need to worry about the excluded values here, the fact that x cannot equal 0 or 2, for example, because we can't divide by 0 or 2. We don't need to state that for this particular problem. That was more when we were dealing with... Actually, you know what? Change my mind. No, we are going to include that. Yeah, I'm sorry, that happens sometimes. We also should include the fact that x cannot equal 0 or 2. We should always state the excluded values with all these fractions. All right, good. If we're subtracting, please be very, 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 very careful with your signs. Same denominators, so a minus a cancels. -4 minus -6 becomes -4 plus 6. So it's really 2 over 6a squared plus 18a, which means they all have a 2 in common. I can cancel that, make it 1 over 3a squared plus 9a. And again, to have our final form, we should factor the bottom as far as possible. So they have a 3a in common, leaving a plus 3. So then we should say that a cannot equal 0 or -3. So if either one of those two cases occurred, we'd divide by 0, and these fractions would not technically exist. So again, we have to go with the excluded values, and we have to make sure we are careful when we combine the numerators. We can think of this as a plus, as long as I make this a -a and a -6. And like as per usual, pen was giving me some issues. There we go. So life's easy. Life's pretty good. It's pretty light work if you have a common denominator. If you have an uncommon denominator, it gets a little more challenging. So what we need to do here is we need to factor both denominators as far as possible. So we'll... Stupid pen, I swear. Alright, hold on. Alright, so I believe the pen is working now. So equals, there we go. So we want to factor our denominator. The x squared minus x minus 6 will factor as x minus 3 and x plus 2. And then the other denominator will factor 5 out, leaving x plus 2. So first what we notice is our denominators have an x minus 3 and x plus 2. So we need to include the fact that x will not be equal to 3 or -2 eventually. Now, let's take a look at our two fractions. Well, both fractions have an x plus 2 in the bottom. That's good. But the left fraction does not have a 5 in the bottom. The right fraction does not have an x minus 3 in the bottom. So we need to take that into account. So we're going to multiply this fraction by x minus 3, top and bottom. We're going to multiply this fraction by 5 on top and bottom. Because now we'll have the exact same terms in the bottom. First fraction will be 5x minus 5 over our 5 and then x minus 3, x plus 2. And then minus the 4x minus 12 for the second fraction. And again, the 5 and the x minus 3, x plus 2. Because we're subtracting, we can think of this plus a negative 4 plus 12x. So now when I combine like terms, 5x plus negative 4 is just x. Negative 5 plus 12 is positive 7. And again, we have our 5x minus 3, x plus 2 on the bottom. Where again, x cannot equal 3 or negative 2. Okay, so that's the idea behind how we get a common denominator with algebraic expressions. We want to factor the denominators as far as they possibly can go and make sure every single term in both denominators, they have everything in common. So we started off with x plus 2's for both of them. Left fraction was missing a 5, that's why I multiplied by 5's. Right fraction was missing the x minus 3, that's how we multiplied by the x minus 3's. Okay, so let's take a look at another one like this. So sometimes we don't have to factor at all. That's kind of nice. We have 3 over x minus 6 plus 4x over x plus 2. There's no factoring involved, but they also have no common denominators. We're noticing that we cannot have 6 or negative 2 in that denominator spots. Well, I'm missing the x minus 6 in the right fraction, so I'll multiply this by x minus 6. I'm missing the x plus 2 in the left fraction, so I'll multiply this one by x plus 2. That's an arrow, not a 7. So then when we distribute, we'll get 3x plus 6 over the x minus 6 and x plus 2. And then plus the 4x squared minus 24x over, again, the x minus 6 and x plus 2. So when we combine the two numerators, 4x squared doesn't change. 3x minus 24x will give us a minus 21x, and then plus 6. All over x minus 6 and x plus 2. Generally, you don't need to be concerned with the possibility of things factoring and have to worry about that. Looking at this real quick, I don't see any possibilities for factoring that first expression, so we're good. So that's our final answer, where again we have to state the excluded values x cannot equal 6 or negative 2. Alright, so that's the whole idea behind getting your common denominators. Always make sure you factor if you have quadratics. If you don't, that's fine. Just simply make sure the missing factor is on each fraction. Now, let's give this a little twist. Make this a little more exciting, a little more interesting. This is kind of boring. This is kind of this is light work. This is easy work. Let's combine the previous video into this video. So we're doing the numerator is 2 fractions subtracting. The denominator of the fraction is 2 fractions adding. And again, this is dividing these things. So this is good. This is nice. Here's what we want to do. We want to get we need to combine the fraction, the numerator, the 2 fractions to a single fraction, and do the same thing for the denominator. Because then we're dividing 2 fractions. And then we can do our keep, change, flip, and multiply the reciprocal. So, for the top fraction, we have 3 over 2x plus 3 minus x over x plus 1. So we need to multiply the left fraction by x plus 1 and the right fraction by 2x plus 3. We will get 3x plus 3 over 2x plus 3x plus 1 minus 2x squared plus 3x over again the 2x plus 3 and the x plus 1. So again, if we think of this as a plus, then there's a negative 2x squared and a negative 3x. So the negative 2x squared doesn't change. 3x plus a negative 3x cancels, and then just plus 3. This is over our 2x plus 3 and our x plus 1. We're noticing again we have 2x plus 3 and x plus 1. We're going to have to state the fact that x cannot equal a negative 3/2 or a negative 1. Can't have zeros in those fractions. Alright, then we have the bottom. So we have the 2x over x plus 1 plus 5 over the 2x plus 3. Well, again, we'll multiply the left fraction by the 2x plus 3. Multiply the right fraction by x plus 1. Just have a whole bunch of fraction problems going on here. Isn't this beautiful? Isn't this wonderful? Math is amazing. So when we distribute, we'll get 4x squared plus 6x over 2x plus 3, x plus 1, and then plus 5x plus 5 over again 2x plus 3, x plus 1. Which means this, when we combine, will be 4x squared plus 11x plus 5 over again 2x plus 3 and x plus 1. Well, we've now simplified both numerator and denominator, top and bottom. Now all we have to do is we need to now rewrite this. So if it's a fraction, top over bottom, that means we're going to do the negative 2x squared plus 3 over our 2x plus, I'm getting tired of writing this, to be perfectly honest, 2x plus 3 and x plus 1 divided by our 4x squared plus 11x plus 5 over our 2x plus 3 and our x plus 1. So we talked about in the previous video, keep, change, flip from when we divide by fractions. This will be negative 2x squared plus 3 over the 2x plus 3 and x plus 1 times our 2x plus 3 times x plus 1 over the 4x squared plus 11x plus 5. Well, now we can reduce it. We're noticing 2x plus 3 is top and bottom, x plus 1 is top and bottom, they're gone. Resulting, the two other pieces left over cannot factor in any way. So we're going to get negative 2x squared plus 3 over 4x squared plus 11x plus 5, where again, x cannot equal negative 3/2 or negative 1. There's your final answer. A lot of work for it, but it's still necessary. A lot of times for these kind of problems, you'll notice the denominators for both top and bottom will be the same. That's done like that on purpose to make the problem just a little bit easier to deal with, but obviously they don't have to be. We could have easily have completely different denominators and just get into this wonderful, wonderful mess of factoring and canceling and just pure beauty. That's all you need to worry about. Okay, so that's it for this video on adding and subtracting fractions. Again, the key really is making sure your denominators are the same. And if they're not, you're just multiplying by an opposite factor to make them the same. Okay, so again, appreciate you guys watching. And I will see you guys the next time. So I guess that means McMath is out.